Winds on our planet are created by the difference in temperature between the equatorial regions and the poles. They are the flow of air from high to low pressure. As warm air rises in the tropics, it flows towards the poles, where the air pressure is lower. On its way there, the air cools and sinks again, conversely leading to higher pressure and counterflows near the surface. This way, winds are basically redistributing heat energy over our planet. This process of energy redistribution, combined with the Earth's rotation, generates the weather patterns we experience every day and makes our planet habitable.
If we didn't have any winds in the atmosphere, then it would be very, very hot in the tropical regions and very, very cold in the northern regions. We would not be able to live in Europe because wind is a very effective transport of energy. It's similar to the draft in your house. When you open a window, you get flow in and change the temperature in the house. The wind have the same effect for the circulation. So that's the main reason for the wind.
Since the dawn of time, mankind has been trying to assess winds and predict the weather. Where in ancient times farmers had to consult soothsayers and oracles, today we have more modern ways of predicting the weather. This is the European Centre for Medium-Range Weather Forecasts in Reading, UK, a partner of ESA in the Aeolus programme. They make global numerical weather predictions based on in-situ and satellite measurements. Their forecasts include detailed weather predictions within the next 2 weeks, less detailed forecasts for the next month, and indications of likely trends up to a year ahead. These numerical predictions are the basis for weather reports worldwide, and they are important for society.
The reason why it's important for society is probably the most important reason is it can save lives because occasionally the weather is extreme. If we have extreme storms, and it's very important that we warn people about this in advance. So the more accurate we can make our forecasts, the earlier we can advise people to take action to avoid being involved in weather disasters.
In order to run weather models based on numerical weather prediction, it is important to have sufficient and accurate data on the current state of the atmosphere, such as global wind and temperature, as it is their interaction which drives our weather. Today, this data is mainly obtained via in-situ measurements of weather balloons, ground stations, and data from aeroplanes. Satellites are used to measure temperatures from space and track winds indirectly through cloud movement and wave movement on the ocean's surface. However, there remains a significant gap in wind data over vast land areas, the oceans, and especially between the altitudes of 10 to 30 kilometres, where there is no in-situ data available.
So we need to know the winds in remote areas such as the oceans because those winds in those areas determine what the weather will be downstream in, for example, over well-populated areas such as Europe many days later.
To address this need for more accurate global wind profiles, ESA will soon launch the Aeolus Earth Explorer satellite, with the ECMWF processing the data. If Aeolus can deliver the long-awaited wind data, meteorologists hope more satellites like Aeolus will be launched in the future. For numerical weather forecasts, it's important to have accurate wind measurements today to predict the weather tomorrow.